And now it is time to study orbital mechanics. So get your brains out and your notebooks and pencils. Um, First, let's look at what an orbit is. It is a closed path around which a planet or satellite travels. That is a beautiful definition. We talked a little bit about Kepler in the 1600s. He found that they were ellipses, not circles. That was amazing. That just by the power of observation, with his notebooks and using Brahe's notes. Remember, it was Brahe that was the one who really kind of took a lot of those details, but he analyzed those things and looked through telescopes and didn't have a way to enter them in a computer because there were no computers. And he figured out that they were ellipses, not circles. That is incredible. So be impressed. Satellites are orbit Earth as an ellipse. They do not orbit in a perfect circle if they're natural. So natural satellites are like the moon is a satellite around the Earth. An asteroid or something is also a satellite. Planets are satellites around the sun. Natural satellites are always ellipses. Write that down. Human-made satellites, like a communication satellite, that can be circular orbit because we can control it. But when something is captured, a flyby is captured by the gravitational force of a planet, the gravitational attraction of a planet, it is never going to become fully perfectly circular. So know that natural satellites are elliptical, but human-made could be circular. Elliptical orbits remain fixed in space. So if you have an orbit that's going around the Earth like this or like this, no matter where the Earth is around the sun, that orbit is still the same. That was really difficult to do. That orbit doesn't change and rotate facing the sun. It doesn't know where the sun is. It just knows it's doing that. So an ellipse is a two-dimensional shape produced by a plane intersecting a cone. So if we slice that cone, we get this elliptical shape. If we slice at perpendicular to the cone center line, which is basically this bottom piece here, if you pretend this cone extended down and we slice it off, then that's a circle. So slicing perpendicular to the center line here makes a circle, but at sort of an angle makes an ellipse. And the other thing you gotta note down is major and minor axes. So make sure you draw this, and minor is here, major is the long distance, and semi-major to semi-minor, that's just half of those. So please note both of those down. And now you get to try this out firsthand by making your own ellipse. So the last couple things I wanted to point out, a couple definitions here. A circle is a set of fixed points from a center point. So all of these points along the outside edge from the center are fixed. They're all the same. So A, the length of this line is the same no matter where you are in the circle when you measure that distance to the center. It's not the same for an ellipse though. Ellipse has two foci instead of a center. And when you take the length of A and the length of B and add them together, no matter where you are on the outside edge of the ellipse, that value is always going to be the same. So if I have a point here directly below A, then that distance, or directly below this foci, that distance here is going to be a lot less than this distance. But the sum of those two is going to equal the same amount that it was up here as the sum of these two. So that's really kind of what an ellipse is. Now, your turn. What I want you to do is get a piece of scratch paper. You can get a piece of cardboard, just something you can draw on, and you're going to take a pencil and a couple push pins. So you're going to push, and that's why I'm thinking cardboard might be a better option for you. But if you take some push pins and put them into the cardboard to represent the two different foci, and then wrap a piece of string around both of them so that you can see this line here represents string, and there would be one more piece of string that goes here. So it's a big loop of string, just a giant loop. So you're going to take a piece of string, tie it into a circle, and it's going to hook around this, and around the tip of your pencil. So my pointer here is the tip of the pencil. And as I move that pencil, then keep that string tight all the way around, and it should form into an ellipse. So what I want you to do is I want you to test out different distances from A to B. And let's see if we can, learn something about the semi-major and semi-minor axes. At what point is the semi-minor axis half the semi-major? What is the distance from A to B? Let's see if you can find some relationships with regards to things on the ellipse. So go ahead and do that. And once you have something on your paper, you've tested a few of these things out, call me over. I want to see it.